All right, this is one of the free responses on the 2019 AP exam, and I think it's a pretty good one. So they give you this continuous function here, that's graph f, always make a careful note of that. And anyway, it says it's defined between -6 and 5, but notice they're only giving us -2 to 5 in the graph, which is kind of interesting. They also tell us that the point 3 minus radical 5 is on that graph, okay? Part B, they tell us the value of the integral between -6 and 5, which of course includes part of the graph that we haven't seen. We want to use that to find the value of the integral between -2 and 6, which again is this part that's off here somewhere. So I'm thinking here that I can break integrals up into pieces. And for example, I could do an integral from -6 to -2, and then an integral from -2 to 5. So here's what I've got. This is the one that they tell me is 7, okay? I'm going to break this up in the integral from -6 to -2, which is off our graph, okay? And this is from -2 to 5. -2 to 5 is on our graph, so we should be able to handle that last part here. So that's what I'm going to focus on now. A couple of things here I'm noticing. We've got a triangle that's a 1 by 1 above the axis and one below the axis. Those two are going to knock each other off. Okay, we've got a 1/2 by 1 here. One is under the axis and the other's above. Those are going to knock each other off. So to find the integral, really I've got this rectangle, this square here. This is a 2 by 1 triangle. So this triangle would have an area of 1. That square would have an area of 1. So this little trapezoid here has an area of 2. And then I need to find this region here. I could block the whole thing in. That's a square, right, with an area of 9. And I'd be subtracting the area of that circle out of that. That's a circle with a radius of 3, so the area of that circle should be 9 pi, but this is only a quarter circle, okay? So the area of the rectangle is 9. The area of the circle would be 9 pi over 4. So if I take 9 minus 9 pi over 4, that should leave me with this little part over here. And anyway, so if we put all that together, so we've got the region that has an area of 2, and we have the square that has an area of 9, and then we're removing the 9 pi over 4 from that, okay? And so if we put those two things together, that's 11 minus 9 pi over 4 is this integral here. So here's what we've got. So we've got 7 equals, we'll call this integral, we'll call it I for integral, plus 11 minus 9 pi over 4. And then we should just be able to solve that equation. Subtract 11 minus 9 pi over 4 from both sides. And anyway, if we end up doing that original integral value is just equal to, let's see, 7 minus 11, it looks like -4 minus 9 pi over 4. Is there any chance that that's correct? Let's see. Oh, I have to be careful here. Let's see, that 9 pi over 4. I think I was signed wrong here somewhere. Let's see here. 11 minus 9 pi over 4. Oh, we're subtracting all of this. Whoops. So we're subtracting 11 minus 9 pi over 4, so that's going to give us plus 9 pi over 4. Oops. Okay. You got to be careful with that. All right. We'll look at the grading key for this one here. You can kind of see that set up there. That's a lot going on there. But you get a point just for showing that you can break the integral up, and then actually finding the area of that one region, and then your final answer. So I guess I would have gotten 2 out of 3 on that one. Okay, let's go ahead and look at the next question here. Part 2 asks us to evaluate the integral between 3 and 5 of 2f prime of x plus 4, okay? So we know, of course, if you have a sum of integrals, we can break that into 2 separate integrals. So I think I'm going to do that first, and this is between 3 and 5. And so anyway, if you're wondering what I'm doing here, here's what I've written up for this part. Okay, I can factor out the constant. We're just going to have a 2 out front. The antiderivative of f prime is f of x. Okay, remember fundamental theorem, you got to take the integral first. Okay, so the integral of f prime is f. It was being multiplied by 2. Okay, plus the integral of 4 with respect to x is 4x, and then we're going to evaluate this whole statement between 3 and 5. So we'll go ahead and sub all this in. That's going to be 2 times f of 5 plus 4 times 5. We're going to take that answer and we're going to subtract this integral if we put in the 3 and the 4. So that's 2 f of 3, and then plus 4 times 3. And be careful, we want that whole result, and we want to subtract this whole result. So make sure you're using parentheses here when you're setting this up. All right, so go back to the graph here. We need f of 5. F of 5 is equal to 0. Well, that's nice. 4 times 5 is 20 from that other statement. F of 3 looked weird here, but then they tell us that f of 3 is 3 minus radical 5. So 2 times f of 3 plus 4 times 3, which is equal to 12. Let's put all that together here. So we got 20 minus 6 minus 2 radical 5 plus 12, 20 minus 18 minus 2 radical 5. 20 minus 18 is 2, minus a negative 2, that's going to be plus 2 radical 5. So it looks like 2 plus 2 radical 5 if my hurried calculation works out. So let's see what's going on there. Yes, that's correct. Okay, let's go on to part 3. Part 3 says we would like to find the absolute maximum value of g on the interval between -2 and 5. And they give us a new function g, okay? Notice that g is the integral of function f. So for example, if I wanted g of 0, for example, I'd find the integral between -2 and 0. Now, max-min problems. Remember that maximum and minimum values happen at critical values, places where the derivative is equal to 0. Okay, so this is nice because I have an integral function here. If I take the derivative of an integral function, it's going to knock out that integral. Notice there's no inside function there. Like if that had been a 2x or something like that, we'd have to apply the chain rule here, but we don't have to. So g prime of x is just going to be the same thing as f of x. Okay, and again, we want to know where g prime is equal to 0. So I can make a little number line here. So again, g prime is the same thing as f, and I want to know where g prime is 0. So notice I label these two things equal to each other, so I remember that anytime I go look at the graph. Okay, so g prime, I want to know where g prime is 0. G prime is the same thing as f being 0, and that happens at -1, and that happens again here at 1/2, and it's going to happen over here at 5. So they call these the candidate values. So we've got -1, we've got 1/2, we've got 5. Remember that you could have a relative maximum or minimum at the endpoints of the interval too. So we are going to have to go back and look at -2 as well. So these are what are called our candidate values here. Okay, and we just need to find g at each of those values. Now, does it tell us any values ahead of time here? Well, let's go back. So function g here, we need g of -2. Function g is just the integral from -2 to a value. So g of -2 is just going to be 0, right? Because that's the integral from -2 to -2. G of -1, that would be the integral from -2 to -1. Notice that's a half triangle there. That's going to be 1/2. That's above the axis. G of 1/2 is that other value that we need to find here. By the way, I was going to make a number line here, but to see where g is increasing and decreasing based on the sign of g prime. But I realized this is just a relative maximum or minimum problem. So I just need to check all the function values of g at the endpoints and at the places where the derivative is 0. And the highest value is the maximum. I mean, that's it. So anyway, so g of 1/2, if we go here and check that, all right, g of 1/2, so we've got this half triangle that knocks off that half triangle. and then we have this one that's below the axis over here. So that looks like that's going to be a negative 1/2. Oh no, that triangle's a 1/2 by 1, so that'd be negative 1/4 would be the area of this little triangle right here. Okay, and f of 5, I think we already found f of 5 earlier. That's just the integral from -2 to 5. That was 11 minus 9 pi over 4. So a lot of times we have previous things. So the maximum is going to be the largest value here, and I'm pretty sure, I'm going to stick that in the calculator, but I'm pretty sure it's that one. So let's take a look at their answer here. So notice, they check the candidate values here. So you get a point just for saying that G prime is the same thing as F. Including -1 as one of your possibilities apparently gets you a point. And then your answer here, notice that the maximum value, and again, they're talking about a y value when they talk about a value of a function, is that 11 minus 9 pi over 4. Okay, so good number of points there. And finally, the last part. We want the limit as x approaches 1 of that statement right there. Well, first of all, try substituting. That's 10 to the first minus 3 times f prime of 1. We'll go look at that in a minute. F of 1 minus the inverse tangent of 1, or the arctangent of 1. I'm going to write it as inverse tangent. Remember, you take the tangent of 45 degrees, or you're always working radians on the AP exam, so 45 degrees is pi over 4 radians, or you could stick that in your calculator, but just make sure you have the radians set up there. But anyway, that's a big thing that's going on there. So anyway, let's go evaluate those other values. Let's see, f prime of 1. So I need to evaluate f prime of 1 and f of 1. So f prime of 1 would just be the slope at 1, which looks like it's going to be 2, if you look at that slope there. And f of 1 is equal to 1. So if we put all this together, we've got 10 minus 6 over 1 minus, remember that's going to be pi over 4 angles will give you a tangent of 1. If you're wondering, you can make a 45, 45, 90 triangle here. Opposite over adjacent is 1. That'd be a 45-degree angle. All right, so it looks like 4 over 1 minus pi over 4, if I didn't mess up any signs, so that's interesting. Looks like we're not going to have to take derivatives or anything like that. And remember, you can leave it in that form. They do not want a decimal approximation on that. And there's the correct answer. We got it.